Hey there, you wild animals. Delfeld here. And as I mentioned yesterday on Thursday, I wanted to record a little video showing you the solution for the second problem or the second slide in the notes. So this is from the notes that we introduced on Thursday, March 4th. All right. So it's the second slide. The video here that I have linked in there, that's for the first one. That's for the first slide. But I wanted to record the solution for the second one so that if you wanted to take a look at it, you can see it. All right, so this one involves a covalent bond between one phosphorus and then three hydrogens. All right, so let's look over here at our instructions. We need to create the Lewis dot model for each atom. All right, now remember there's a few things that go along with that. If you have different elements, well, the one that has the fewer atoms is usually going to go in the center. Another way to look at it or to think about it is which one needs the most help, which one needs the most valence electrons, which one needs more dots, more additional dots. So let's see what we got. We got phosphorus, we got hydrogen. Well, over here in the periodic table, you see hydrogen is in column 1. So it's got 1 dot. Remember, hydrogen's the only one that doesn't want 8. Hydrogen's the only one that wants 2. It only needs 2 total dots. So if it has 1, it means it only needs 1 more. So we have phosphorus over here now. Phosphorus is in column 5, and it's going to want 8 dots. So if it's in column 5, it currently will have 5 dots, meaning it needs 3 more. So phosphorus needs 3 more. Hydrogen needs 1 more. So who needs the most help? Who needs the most additional dots? Phosphorus. So we're going to put phosphorus in the middle. All right. Not to mention there's only 1 phosphorus and there's 3 hydrogens. So, that kind of fits both of these criteria right here. So phosphorus is going to go in the center, and we're going to surround it with the 3 hydrogens. Okay. It doesn't really matter where you put the hydrogens as long as you somehow surround the phosphorus. So I'm going to put one on the left, on the bottom, and then on the right. I think I'm going to move these a little bit away so it works out better. All right. And then we need to place single electrons on the sides nearest other atoms. So we'll put pairs of electrons away, and we're going to use different colors. All right. So let's go ahead and place some electrons in here. So hydrogen with 1 dot, put that one there. A different hydrogen, different color. 1 dot. Notice how I'm putting them in like the center nearest the other atoms. And then hydrogen over here as well. Another dot. All right, let's get phosphorus in there. Remember, phosphorus has 5 dots as it's in column 5. So there's 1, and then 2, and then 3, 4, and then remember, we want to double up for our 5th one. We got to find a buddy. However, remember, you want to put the pairs kind of away. You want to put single electrons on the sides nearest other atoms. So I don't want to put a second one on this side. I don't want to put a second one on this side. I don't want to put the second one on this side. So I'm going to throw it up here on the top. Because basically the way it is, if you haven't noticed, electrons like to be in pairs. Well, they will be in pairs if they need to be. And so that's kind of the case we're in right now with bonding. So if we can get one in a pair, or if we can get 2 electrons together, then they're set. But you don't want to put a pair over here on the left because, we're going to be sharing some. So that just wouldn't work. You wouldn't want to put a pair down here or a pair over here. So we're going to put the pair up here. So they're kind of away and they're already happy. We're going to leave them alone. So we have our 5 for phosphorus. Now as number 2, we got to connect the single electrons of different atoms with the gray stick with these bonds. And this is just indicating that they are now sharing these electrons. So I'm going to put one right there over those electrons. I'm going to grab a vertical one right there because those are going to share. And then these are going to share. That's why we put the singles nearest the other atom so we can easily share them. So now each stick, each gray line represents 2 shared electrons, and we're going to confirm that each one has the 8 dots that they need. However, remember, only phosphorus in this case wants 8 because hydrogen is an exception to that rule. Hydrogen only needs a total of 2 dots. So this hydrogen, well, it's got 1 stick coming off of it, so that hydrogen's got 2. It's good. Hydrogen here has got 1 stick. That stick represents 2 electrons. Good. Same thing here. 1 stick represents 2 electrons for hydrogen. And then here we got phosphorus. Phosphorus has the 1, 2, but then it's sharing 3, 4, 5, 6, 7, 8. All is well. Looks good. We'll come over here. We'll write a formula. Notice how I made the boxes in a certain way that hopefully you would have put it in the right way. So P should go in the first one. Phosphorus should go in this first one because we don't need a subscript. We don't need the little number because there's only one of them. So you should put P in that first one and then hydrogen over here. And then in that little box, you'll put the number 3 because you do need to indicate that there's 3 of them. And then we got to come up with a name. Remember the name? To get a little help on writing the name, we'll look at slide 3 for the naming rules and the prefixes. So the first element gets a prefix added to the front only if there's more than one of them. Okay, so with the one we did on slide 1, there were 2 H's, 2 hydrogens. That's why it was dihydrogen. But if there's only one of the first thing, in our case, phosphorus, you don't need a prefix. So if I come back, I see, well, there's only one phosphorus, so I don't need a prefix on that first thing. So I'm just going to write in plain old phosphorus. You don't need monophosphorus. You don't need a prefix if there's only one of the first thing shown. I don't know why that's the case. This is just how it is. Come back and look at the second rule. The second element always gets prefix added to the front. And remember, we replace the ending with "ide." So there were 3 hydrogens, remember? So we're going to use the prefix tri, like tricycle or triangle, right? And we're going to throw that over here. Oops, come on. Tri, and then it's not trihydrogen. Remember, we got to change the ending a little bit. In this case, we're going to get rid of the last 4 letters to make it trihydride. All right, there you go. So we got phosphorus trihydride, and we have our Lewis dot model right there.